Welcome to Study Loop.
Okay, we're looking at question 28.60, where we have an electron moving in the vicinity of a long straight wire that lies along the x-axis. And the wire has a constant current of 9 amps in the minus x direction, so that's to the left. And this electron is positioned at point 0, 0.20, which means that it's 0.2 meters above the x-axis. This is the y direction up here. And the electron's velocity is expressed in terms of components. So we're told that it has a velocity of 5 times 10 to the 4th meter per second in the I hat direction, which is the plus x direction, that's to the right, and minus 3 times 10 to the 4th meters per second in the minus j hat direction, which is the negative y, so down direction. And we're asked to calculate the force that the wire exerts on the electron. So the force can be expressed as a cross product here, the charge, which is q, times the velocity of the particle, here is the electron, and then the cross product of that with the magnetic field that's exerted on the electron. So first, let's calculate the magnetic field. The magnetic field from an infinitely long wire with it carrying a current at a given distance r is given by this formula. So just looking at this quickly, we have all the components that we need here. We have I and we have r already determined. So this is something that we can easily calculate just by plugging in numbers. So now let's go back to the force. We have the Q, the charge of the electron. I've written it down here. That's just a constant that we know. And then the velocity, like we've said, is split up into two directions. So first, let's think about the direction that this magnetic field exerts at this point. So we have the current is going to the left. So if we point our thumb in the direction of the current to the left using the right hand rule, our fingers are going to curl into the page up at this point. So this is going to be, I'm going to represent this as an X here. The magnetic field is going into the page. So this is going to be the negative Z direction or the minus K hat direction. So what we're going to need to do is calculate the component of the force from each of these velocity components separately. So let's start by calculating the component of the force from the 5 times 10 to the 4th direction going in the plus x direction. So we have F equals, let's just use this, F equals Q. And then looking at, we have the plus x direction here, we're going to need to take the cross product of this velocity. So we're using this 5 times 10 to the 4th. We're going to need to take the cross product of this velocity with the magnetic field. So using the right hand rule, that gives us the plus y direction or the plus j hat direction for the result of this. And since these two vectors are completely perpendicular, we don't have to worry about the angle between them. So we're just going to be able to directly multiply this by b, which we have over here. And this is going to, again, be the plus y direction, which is going to be a j hat component. Now, when we come over here and plug this value in for q, notice that q is negative since the electron has a negative charge. So when we plug this in, this is really going to be going in the minus y direction or pointing down, but we can leave this written like this. So this is the component. I'll add the hat for the vector here. This is the component due to this part of the velocity. So now let's take a look at the component from the other part of the velocity, this minus 3. So it's going to be the same thing, except now we have, instead of this is going to be 3, and we have another minus sign. So that minus sign is going to cancel out with this minus sign out here. So we're going to end up with a positive term overall. And now we just have to actually figure out the direction. So again, we're taking the cross product of the velocity, which is down, and the magnetic field, which is into the page. So when we take that cross product, we're going to end up with a component in the, let's see, QV is down, crossing that into the page is going to give us something to the right, which is going to be the positive I hat direction. So that's going to be this right here. And now all we have to do is actually plug in this value for B, plug in I into here, plug in R into here, and that should give us our actual numbers when we start calculating this out. So that's going to give, for our first term, we should get let's see, plugging all of this in. So we should get minus, so we're going to get minus 4.32 times 10 to the minus 20. And this is newtons, remember? And the other component is going to be 7.2 times 10, also to the minus 20. And this one is, oops, I've written these backwards. So this one here is the first one, which is the J hat component. And then the second one is going to be the I hat component. So normally we sometimes want to write the I component first, just for convention. So when we end up with this, and let me just add the hats here, this should be our final answer for the force. This is the magnitude. Both of these are going to be in newtons, and the directions are now written correctly in terms of the components, I hat and J hat.